Okay, so today we're going to talk about division of polynomials, and we're going to talk heavily about synthetic division, which is kind of fun. And before we get into that, there's some terminology that we need to talk about. And it has these words dividend, divisor, quotient, and remainder. And the one you probably are least familiar with is dividend. But in other words, if you take a number like 4 and you divide it into 48, and you get a remainder of 0, okay, the 4 is the divisor. And I think that word probably comes pretty naturally to you. The 4 is the divisor. The 12 is the quotient, which I think that's probably, you know that. The 0 is the remainder right next to this word whenever I made this mess. And the dividend is underneath the radical symbol. That's where the dividend is. So there's the names of all the pieces of division. And this is referred to as long division. Okay? There's all the names of all the pieces when we do long division. Right, so there it is. So I'm pretty sure you know divisor and quotient. I know you know remainder. So it's that dividend piece that you might be a little new at. Okay, so then it comes down here, and once you get all the names settled in your mind, then it talks about long division. And I'm going to do a simple example with long division. When you take 175 and divide it by 4, and this is stuff you learned back in elementary school. And when you did this, you took 4 into 175, and you said 4 goes into 17 4 times, and you put the 4 on the top. And then you said 4 times 4 is 16, and I'm supposed to do something here. Oh yeah, I'm supposed to subtract at this point. Okay, so you were told many times by your teacher, don't forget you subtract those numbers. And so you subtract them, and then, you're supposed to bring that 5 down. I don't know why, but I'm supposed to take the 5 down, so I do, right? Then you say 4 goes into 15 now. Go down to that number down there. 4 goes into 15 3 times. You put the 3 at the top. 3 times 4 is 12. Oh yeah, don't forget you're supposed to subtract these numbers, and then you get a remainder of 3. I cannot imagine how miserable it must have been to try to teach this process, because there's really no logic at all. You're just doing what someone tells you to do all the way through, which is crazy. I mean, it's insane. But we all did it. We all did it. Okay, and then we say the answer is 43 and 3/4, which is a mixed number. That's what we did. So you memorize this process, and you get good at it, and you do it over and over again. This might hand you a calculator. Right. Okay, but anyway, so now we're supposed to do the same thing with that polynomial in part B. We're supposed to take 2x cubed minus 11x squared plus 13x plus 15 and divide it by 2x minus 5, doing the same thing, same process. Okay, so that means 2x minus 5 goes into 2x cubed minus 11x squared plus 13x plus 15. And you don't hit the brakes. I mean, you just keep rolling with this. And the focus is, how many times does 2x divide into 2x cubed? Well, it goes in there 1x squared times. And so, just like you put the 4 on the top in the number example, we put the x squared at the top. Then we say x squared times 2x is 2x cubed. And x squared times a negative 5 is a negative 5x squared. And then we remember, you're supposed to be subtracting these. So we change the signs and add. So then when we add, the first column is 0, and the second column is a negative 6x squared. Then we just go on faith with the procedure we were taught. We bring down the plus sign and the 13x. And now we say 2x divides into negative 6x squared down here at the bottom. Just like 4 into 15, we take 2x into negative 6x squared, and we say, that goes a negative 3x times.
But why is it negative?
Because a positive 2 into a negative 6. 2 into negative 6. And then we multiply through. Negative 3x times 2x is a negative 6x squared. Negative 3x times a negative 5 is a positive 15x. We don't forget we're supposed to be subtracting, so we come in here and we change the signs and add, because we're like adding the opposite now that we changed the signs. So the first column adds to be 0 like it's supposed to, and I get a negative 2x, and I bring down the plus 15. Then I say 2x goes into negative 2x a negative 1 time, which I put up at the top where the quotient's supposed to be, and I multiply through. Negative 1 times 2x is a negative 2x, and negative 1 times a negative 5 is a positive 5. I don't forget that I must change the signs, and once the changed signs, we add the opposite, and my remainder is 10. Okay, so I'm finally done. I have a remainder of 10. So, don't forget your words. The 2x minus 5 is your divisor. The x squared minus 3x minus 1 is your quotient. This 2x cubed minus 11x squared plus 13x plus 15 is your dividend. And the remainder is 10. Okay, there's all my words. Okay, there's all the terminology. Now, just as when I took 4 into 175 and got a remainder of 3 and I wrote this mixed number out of it, we can write a mixed number out of this division of polynomials. And the way we do that is we say, okay, well, the quotient is x squared minus 3x minus 1. And then I take the remainder over the divisor. So then I use a plus sign and I put 10 over 2x minus 5. So my mixed number, when I had polynomials, this is like your mixed number, but you put a plus sign between this trinomial and that fraction, that rational. Okay? So this is not very fun. It's extremely time consuming. Very time consuming. So there's got to be a shortcut, and there is a shortcut. And the shortcut is to not do this long division, but to do what we call synthetic division. Okay? So the shortcut is in part B, which is, that long division is not very easy, number one. Okay, not very easy, and it's very lengthy. So we're going to do something different. We're going to use this synthetic method called synthetic division to do the same type of thing. So here we do this, use synthetic division to divide. Well, I'm not going to do the long division with the bar and everything. I'm just going to do a different shortcut method. Okay, the shortcut method says your divisor, take the opposite of that sign, which is like a negative 8, put an 8 in the half box. Okay, put an 8 in a half box. Then draw a bar here, and under the bar, put the coefficients of this large dividend. So it's a 1x cubed, so I put 1. Negative 13x squared, so I put negative 13. 46x, so I put 46. And then a negative 49. So that's your start in your synthetic division. I draw a line down here, and I bring the 1 down. So this is your setup. The process now is to multiply, then add. Multiply, then add. Multiply, then add. Okay, so the first thing I do is multiply. I take 8 and I multiply it times 1, and I put it up here underneath the negative 13. That's my multiply. After I multiply, I then add. A negative 13 plus 8 is a negative 5. Now I multiply, add. I multiply 8. Whoops, I lost my line. I now multiply 8 times negative 5, which is a negative 40. Multiply. And then I add that column. 46 plus a negative 40 is a positive 6. Multiply, add. Okay, then I do this again. I multiply 8 times 6 and get 48. And then I add and get -1. And this last number I put in a square box because this last number is your remainder. Okay, that last number is your remainder. Now, when you had an x cubed to begin with and you divided it by an x, your result will be x squared. You're going to come down 1 degree. So it was x cubed, I'm coming down to x squared. This is going to be 1x squared from my last row minus 5x plus the 6. That is your quotient. That is your answer with your remainder of -1. Okay, that is your answer with a remainder of -1. So, really, when you write it as a mixed number, it becomes x squared minus 5x plus 6 plus your remainder over your divisor. And your divisor was the given x minus 8. Okay, this gets really fast. Right now you're thinking, what in the world? But believe me, when you were taught long division, you felt the same way. Okay, so the quotient is in this bottom row. You have to come down from an x cubed to an x squared. And so this bottom row is the coefficient of all your terms in your quotient. So it'll be x squared x, no x. Or x cubed x squared x, no x. Or x to the 4th x cubed x squared x, no x. Okay, in descending order. Okay, so all of these numbers in the bottom row are the coefficients of your quotient. All right, let's try it again. Okay, the first time you see it, it's going to look bad no matter what. Okay, let's try another one. Here we do it again with one a little bit bigger. Okay, first thing is this is not, your dividend here is not in descending order, which is, they do that purposely to try to mess you up. Okay, that was purposely written incorrectly to mess you up. So the first thing you do is write it as 3x cubed plus 25x squared minus 48x plus 20. So that thing has to be written in descending order. So you have an x cubed, x squared, x, and no x in your dividend. Okay, so you're dividing it by x plus 10. Okay, so you make a half box. And the x plus 10, you take the opposite of the sign, putting a -10 in your half box. Then you put the coefficient of every term in your dividend. So you have a 3 as a coefficient of x cubed, a 25 as a coefficient of x squared, a -48 as a coefficient of x, and a +20. You're going to multiply, then add, multiply, then add, multiply, then add. Okay, here we go. Multiply. -10 times 3 is -30. Now add. 25 plus -30 is a -5. Multiply. -10 times -5 is 50. Multiply, then add. -48 plus 50 is 2. Multiply. -10 times 2 is -20. Now add 0. This is a good thing. This is a good thing. A remainder of 0 makes us happy. Okay, this is a really good thing. Okay, so now, here's where we get the quotient. This was originally this was a 3rd degree polynomial. So my quotient's going to come down to a 2nd degree polynomial. So as a 2nd degree polynomial, I'm going to have an x squared term. So this is going to be a 3x squared. Then I'm going to have an x term, and then I'm going to have no x. Now, with a remainder of 0, I don't have to worry about a mixed number. This is the quotient. Okay, because my remainder was 0. That is the quotient. Okay, let's try it again. Here's another one. Use synthetic division. Okay, this one's a little harder. This one's a little harder. Okay, so if you notice that before my divisors just had x and no coefficient, I need an x there. The truth is that if x plus 10 is a factor and you set it equal to 0, that is the number that goes in the half box. Okay, that is the number that goes in the half box, which is why we have to change the sign. So on number 3 here, I have to, if I set this one equal to 0, I'm going to get 2x equaling 5, or x equaling 5 halves. So 5 halves is the number that has to go in my half box, but they've made it so it's not hard. Okay, so my half box cannot have, it has to have a 5 halves in it. Okay, and this book is kind of interesting that they do this. Our last textbook didn't really do that. Okay, so the number in the half box is 5 halves. Then you have a 2x cubed, a negative 11x squared, a 13x, and a 15, your coefficients. You're going to bring down your 2. You're going to multiply, then add, multiply, then add, multiply, then add. Okay, 5 halves times 2 is 5. And then I add. Negative 11 plus 5 is negative 6. The next one. 5 halves times a negative 6 is a negative 15. Then when you add, you get a negative 2. 5 halves times a negative 2 is a negative 5. And then when you add, you get your remainder of 10. So this doesn't get a happy face. It's not a remainder of 0. Okay, so to write my answer, which this one's going to be like a mixed number because the remainder is not 0, this started as a third-degree polynomial. It has to come down to a second-degree polynomial, or an x squared. So this becomes a 2x squared minus a 6x minus a 2 with a remainder of 10. So to write it kind of as a mixed number, I have to write 2x squared minus 6x minus 2 plus the remainder 10 over the divisor, which was originally 2x minus 5. That is your answer because the remainder is not 0. Okay, so you have to remember multiply, add, multiply, add, multiply, add. And you get really fast at this. Okay, so then it says, part C, let's talk about a remainder and factor theorem. Okay, the remainder and factor theorem. Okay, so they've got this really cool thing that says, well, let's just do an example. It says, use the remainder theorem to evaluate f of negative 1. What that means is take the negative 1 through synthetic division. Okay, synthetic division. So take the negative 1 through synthetic division, and then I'll explain the result. Okay. So this one's also got another problem. We have an x to the 5th term, but we don't have an x to the 4th term. We have an x cubed, and we have an x squared, but we don't have an x. So if you have an x to the 5th, you want an x to the 5th, an x to the 4th, an x cubed, an x squared, and an x. You want all your x terms there. It's kind of like when you did long division, you had to put filler zeros in. It's the same thing. So if we have a fifth degree polynomial, I want an x to the fifth, x to the fourth, x cubed, x squared, x, and no x. So really what this is written as is 5x to the fifth plus, I'm going to force an x to the fourth term in here and just put a 0 on it. I'm forcing another term in there by just throwing a 0 on it. Then I have minus 3x cubed. I have an x squared. I don't have an x, so I'm going to put a 0x in here, minus 4. So this is what they call complete standard form, meaning you have every x variable. X to the fifth, x to the fourth, x cubed, x squared, x, and no x. And you have to have all of them before you do synthetic division. So now with synthetic division, I put a negative 1, I have a 5x to the fifth, a 0x to the fourth, a negative 3x cubed, a 2x squared, a 0x, and a negative 4. Now I'm ready for my synthetic division. Okay, multiply, add, multiply, add, multiply, add. Negative 1 times 5 is negative 5. Now add. 0 plus negative 5 is negative 5. Multiply. Negative 1 times negative 5 is a positive 5. Now add. Negative 3 plus 5 is 2. Multiply. Negative 1 times 2 is negative 2. Now add. 2 plus negative 2 is 0. Multiply. Negative 1 times 0 is 0. Add. 0 plus 0 is 0. Multiply. Negative 1 times 0 is 0. Add. Negative 4 plus 0 is negative 4, which is my remainder. Multiply, add, multiply, add, multiply, add. Okay, now, this thing called the remainder theorem says that when you have a remainder, or really any time you do synthetic division, this value in the half box and the remainder create an ordered pair. They create the ordered pair negative 1, negative 4, which turns out to be a point on the line f of x equaling that 5x to the fifth minus 3x cubed plus 2x squared minus 4. So if I graphed that function, that point, negative 1, negative 4, would be on the line. Okay? So really what happens is when you have a remainder of 0, we can factor and go crazy with the process, and if the remainder is not 0, it's a dead end, and this is the best we can get out of it. It's a point on the line. Okay? So when the question says, what is f of negative 1? F of negative 1 is negative 4. When x is negative 1, what is y? Y is negative 4. Okay, let's try another one, especially since you're just now kind of learning how to do synthetic division. So again, the remainder theorem is the one that says that those two numbers are an ordered pair point on the line. So now again, use the remainder theorem, which means use synthetic division, put a 4 in the half box, and create an ordered pair point, which will be on that line. Okay, so let's check this thing. We have an x to the fourth, we have an x cubed. I'm missing which term? I'm missing x squared. Okay, so I've got to plug in an x squared. Let's just put it right here. Let's just cheat and put 0x squared above it. Then I have x, and then I have no x. So now I'm ready. So through synthetic division, put a 4 in here. I'm going to have a 3x to the fourth, a negative 15x cubed, a 0x squared, a negative 5x, and a 25. Bring down the first number 3. Process, multiply, add. Multiply, add, multiply, add. Okay, multiply. 4 times 3 is 12. Add negative 3. Multiply. 4 times negative 3 is negative 12. Add negative 12. Multiply. 4 times negative 12 is a negative 48. Add negative 5 plus negative 48 is a negative 53. This is a big, oh, ugly number. 4 times negative 53. What in the world is that? 212? Okay, lovely. And then when I add, what do I get? A negative 187? Blah. Okay, so my remainder was not 0, which is the pits. But at least at this point, I can say something about these numbers, and that is it makes an ordered pair for negative 187, which is a point on the line f of x equaling this 3x to this 4th degree polynomial. Lovely. And so the answer to the question is, what does f of 4 equal? And so what does it equal? There you go. Whatever. Look at number 3. This is a different kind of question. Use the remainder theorem to show that negative 3 is a 0 of f of x. What in the world are they talking about? Oh well. If we're using the remainder theorem, I'm supposed to use synthetic division. So let's just use synthetic division and see what in the world happens. Let's just use synthetic division and see what happens. Okay, I got an x cubed, an x squared, and x. I'm good. Okay, so negative 3 goes into 1x cubed, 2x squared, negative 2, 3, and bring down the 1. Multiply, add, multiply, add, multiply, add. Negative 3 times 1 is negative 3. Add. 2 plus negative 3 is negative 1. Multiply. Negative 3 times negative 1 is 3. Add. Negative 2 plus 3 is 1. Multiply. Negative 3 times 1 is negative 3. Add. Oh, yeah. This is a good thing. This is a good thing. So now let's think. The remainder theorem says that this creates this ordered pair point. Now look at the question. Use the remainder theorem, which I just did, to show that negative 3 is a 0 of this function. Does this show it? What does it mean to be a 0? An x-intercept. Is this on the x-axis?
Yes.
Yeah. So we just did it, right? There it is. Yes. This is an x-intercept, which is the same thing as a 0. Okay, so when it says use the remainder theorem, you get in there and do synthetic division and see what happens. Okay, don't hesitate. Here's another one. Use the remainder theorem to show that 2 is a 0 of that. Okay, this means through synthetic division, my remainder better be what? A 0. There we go. Okay, tricky. Here's my x cubed. Here's my x squared. Crud. I don't have an x. And my screen's doing something weird. Get back. Where'd it go? Come back. Oh my. I'm going to scroll down, scroll up. I'm not sure what it's doing. Okay, but I need a 0x, right? I have x cubed, I have x squared, I don't have x. Okay, so I put 2 in here, and I'm going through a 2x cubed, a negative 3x squared, a 0x, and a negative 18. Drop the 2, the first 2. That is what it says, right? Since mine's got this big old black bar on it. Okay, multiply then add. Multiply 2 times 2 is 4, add. 2 times 1 is 2, add. 2 times 2 is 4. This is not a 0. Unless I did something strange. That didn't work, did it? No. This is not a 0. So not a 0, which means not an x-intercept. Because my remainder was not 0. This is just the point to negative 14. So it didn't work. It did not give me a 0. Okay, let's try it. The square root of 5. All right, y'all's radicals need to be pretty powerful now, right? X cubed, x squared, x, no x. Okay. Square root of 5 goes into 1x cubed, negative 4x squared, negative 5x, and a 20. Bring down the 1. This is going to get interesting. Oh my goodness, is this going to get interesting. In fact, I think I better space these a little bit more. Negative 4, negative 5, 20. Oh boy. Okay, the square root of 5 times 1 is the square root of 5. You can't add a whole number to a radical. You can't put them together. So this is a negative 4 plus the square root of 5. Lovely. Now I'm supposed to multiply, right? Okay, what in the world? So if I take the square root of 5 times a negative 4 plus the square root of 5, right? You can multiply anything. So this is a negative 4 square root of 5 plus, because you're going to distribute here, square root of 5 times the square root of 5 is 5. Okay, so right here, oh my goodness, what a mess. Negative 4 square root of 5 plus 5. All right, so I'm supposed to add. Okay, so negative 5 plus a negative 4 square root of 5 plus 5 is going to be the negative 5 and the positive 5 zero out, leaving behind negative 4 square root of 5. Right? When you add those together, the negative 5 plus the 5 is out. Okay, so here we go again. The square root of 5 times negative 4 square root of 5. The square root of 5 times negative 4 square root of 5. 1 times negative 4 is negative 4, and square root of 5 times square root of 5 is 5. Right? So this would be a negative 20. Ooh, yeah. What we got going on here? Yep. This is a good deal here now. Okay, so the radicals, they're just trying to make it hard. They're trying to figure out a way to make it hard. So this now creates the point. The remainder theorem says that this now creates the point negative 5, 0. Is it a 0 of the polynomial? Yep, it's an x-intercept. What in the world's this? Oh boy. Okay. Polynomials can be evaluated over the set of what in the world is that? What are complex numbers? This is the I stuff, right? The I stuff. This is kind of fun. It's kind of cool. All you need to know is that remember I squared equals negative 1. That's the main thing you need to know. And at some point you probably need to also use the fact that I equals negative 1. But the big thing you need to know is that I squared equals negative 1. That's where we're getting to what we call the complex numbers. You mix the real numbers with the imaginaries and you create a world of complex numbers. That's what that's all about. Okay, so again we're using the remainder theorem, but this time they want to say, is 8i a 0 of this polynomial? Well, remainder theorem says use synthetic division. So this is putting this weird 8i in this box. And I'm going to have a 2x cubed, a 1x squared, a 128x, and a 64. And if the remainder is 0, then good for us. Bring down the 2. Multiply. 8i times 2. You kind of treat I as if it's x when you're multiplying, dividing, all that good stuff. So 8 times 2 is 16, so this is just 16i. When you add 1 to 16i, they don't go together. If it was 1i and 16i, you could add them, but they're not both i's, so this is just 1 plus 16i. Now we got to multiply. Okay, so if I take 8i times 1 plus 16i, 8i times 1 is 8i, But 8i times 16i, what is 8 times 16? 128i squared. Okay, but what did we say I squared equaled? A negative 1. So really this is 8i minus 128. Okay, so when I multiply, I get 8i minus 128, which is pretty convenient because when I add that column, I'm going to get 8i, right? Because the 128 minus the 128 knocked each other out, 0 out, and then I just get the 8i. Okay, then 8i times 6i, no. 8i times 8i is what? 64i squared, but I squared is negative 1, right? So it's a negative 64. Now, isn't that convenient? Because that gives me the remainder of 0. So this is the ordered pair, 8i comma 0. Is this a 0 of that polynomial? Yes. So, they're just trying to give you some algebra, some cool numbers to work with. Okay, factor theorem. Here we're finally getting somewhere. Okay. When the remainder is 0, you can factor. That's some pretty important information. When the remainder is 0, you can factor. Okay, here we go. Use the factor theorem to determine if x plus 4 is a factor. Okay, if it's a factor, for it to be a factor, remember I said when you factor in the remainder, if you get a remainder of 0, you can factor. You must have a remainder of 0 to be able to factor. Remainder must be 0. Okay, to be able to factor something, your remainder must be 0. Okay, so the number that goes in the half box is when you set that thing equal to 0. So the half box gives me a negative 4. I have a 6x cubed, an 11x squared, a negative 60, and a negative 32. And if this thing has a remainder of 0, then I'm looking good. Multiply, add, multiply, add, multiply, add. Negative 4 times 6 is a negative 24. You're adding now, so this would be a negative 13. 4 times 13 is 52, am I right? Okay, 52. Add and get a negative 8. Negative 4 times negative 8 is a positive 32. We're in good shape here. Yes, x plus 4 is a factor. Okay, I got lots of space. Okay, so here we go. If x plus 4 is a factor, and we just, but it is, right? We know it is a factor. Yes, it is a factor, right? If it's a factor, that means that f of x, which equals 6x cubed plus 11x squared minus 60x minus 32, can now be factored into x plus 4 times something if x plus 4 is a factor. What do you think the something is? Ooh, let me think. When I did division, that meant the quotient was 6x squared minus 13x minus 8, right? That was one of the first things we did. We've done so much, okay? So guess what? This is going to be 6x squared minus 13x minus 8. We have done the first step of factoring. Because the remainder is 0. Now they didn't know all. We've been doing a lot of this. We could have factored a bunch of times, but they haven't been letting us factor so far. They've been limiting us just by using the remainder theorem. That's pretty cool stuff. Now, do I have time to at least do one more? Yes, I do. You are packing up. I want to do another one. Okay. Okay. What goes in this half box? Okay. So this is a 4x to the 5th. A negative 24x to the 4th, a negative 3 and 18, a negative 1, and good grief, this is a big one. Bring down the 4. 6 times 4 is 24. I add and get 0. 6 times 0 is 0. I add and get negative 3. 6 times negative 3 is a negative 18. I add and get 0. 6 times 0 is 0. I add and get negative 1. 6 times negative 1 is negative 6. And yes. Yes. So, y'all will get faster than me because y'all are really good at this kind of stuff. So this now factors into x minus 6 times,
4x.
there you go, 4x to the 4th, and that would be a 0x cubed, right? Which, you know, we can write it. 3x squared.
Minus 0x minus 1.
There you go. Now, reality is, this is really x minus 6, 4x to the 4th, minus 3x squared minus 1, but this sucker's factored pretty good. How many more are on this handout? Is this one? Ah, okay. How far can I go? Let me do one more then, because I know we're running out of time. So what do I put in the half box?
Negative 4.
Negative 4. So I have careful, I have a 3x to the 4th, and then what? 0x cubed. Negative 48x squared, 8x, and a 32. Bring down the 3. Negative 4 times 3 is negative 12. Add. Negative 4 times negative 12 is a positive 48. Add. Negative 4 times 0 is 0. Add. Negative 4 times 8. Woohoo! See there? You will get fast, and you will have to be very careful because you go so fast that you start messing up. So this is an x plus 4, and then this is going to be a 3x to the power of 3 minus 12x squared plus 0x plus 8. Really fun stuff, guys. It really is. Now, if that remainder is not 0, it does not factor. Okay? If your remainder is not 0, you do not get to factor. And the question says determine if it is a factor or not. Actually, the answer is yes. And then this is the factored version. Okay, so really, there's going to be more than one answer blank in your homework. The answer is yes, it can be factored, and that is the factored form. Okay, so be careful you know how to answer it. What else do I have down here? Some more stuff. Okay, we'll go to the write the equation next time. Fun stuff, though. No, we don't. Let's do it right now. I can do this. Go down to part E. This is fast. I don't have very much space here to write. Anyway, okay, so the question says write the equation. Okay. Y equals something. If 2 is a 0, then I would have to put x minus that number, right? And it's a multiplicity too, so it's going to be squared. If negative 5 is a 0, it's x minus that number. So this becomes y equaling x minus 2 squared times x plus 5. And it makes sense. Your zeros are going to be at 2 and negative 5. It's going to touch at the 2 and it's going to cross at the negative 5. Okay, part 2. If you have a 0 at 4, it's going to be x minus that number. And a multiplicity of 5 says put that binomial to the power of 5.
Yeah.
On the first one, what will we do with the number 3? Like, is there anything?
A degree 3. Okay, if I multiplied this out, isn't this a degree 3? There you go. It is a third degree polynomial.
Oh, okay.
See it? It is a third degree polynomial. They might make you multiply it all the way out in your homework. I'm not sure. Okay, so this one, 4, is a multiplicity 5. Then you have a negative 3, and you're subtracting these things. A multiplicity 2, and then you have a 5 of multiplicity 1. So this becomes x minus 4 to the 5th x plus 3 squared, x minus 5. Is that an 8th degree polynomial? Yes. Okay, you're good. Now we're done.
How'd you get x minus?
It's always subtraction. It has to be subtraction, and that'll make sense a little bit later.